Tuesday. I'm John.
I'm David.
And we're here to talk to you today about the handheld penetrometer.
That might be a better topic than we're thinking about.
It will be. It will be a better topic. So this is a tech talk. This is a story time. We had a... How do we start this?
Well, you know, any design has the potential to have some iteration.
Well, I think it all starts with a client, though.
Yeah.
Any design that we do normally starts out with the client asking us, hey, can you do? And David and I look, sure. Or I say, absolutely. And then David looks at the ASTM and says, I could build that.
It just takes time and money.
Time and money. And that's what we're going to talk about.
It takes more time and more money. And then it takes more time and more money.
So had a client call up.
Yeah.
And said, do you have the ability to test for the evaporation rate when using an ASTM C309 or 1315 membrane-forming curing compound?
Yep. That sounds familiar.
And I said,
absolutely.
Heck yeah, we do.
Yeah, we could do that.
Hung up the phone. I said, hey, David, hypothetical. Have you ever looked at ASTM C305-1319? And he said,
no.
Me neither. So we cracked it open, and we had a long lead time on this. We cracked it open, and we looked at the evaporation test, which used in a different ASTM, C156.
Right.
And we looked up the equipment for it, and the equipment was somewhere around... You remember how much it was?
I don't think we've ever looked in the catalog for less than 25,000. Yeah.
The prettiest one I saw was 47,000.
Yeah, this specialized equipment. I mean, it's expensive. It's expensive for a reason. I mean,
right.
There's not a big market, and it's not easy to make it.
No, as we soon found out. So David looked at the ASTM for the equipment, and I looked at the price, and we were trying to find one. And how did you say it to resources?
It's probably wrong, whatever it was.
I think you said, yeah, I could probably build it for $1,200.
It might have been that, yeah.
And, we had just hired a new lab technician.
Yeah.
He who shall not be named.
Yeah.
Junior. And, he was very good at taking your concept and drawing it out on paper. Mm-hmm. Like, I still have the copy. Very, very good job at, we had the discussion, took notes, but then building it. And, hey, listen, we learned a valuable set of lessons.
Yeah, no doubt.
One of them was don't trust a new technician with a monumental task like that. I mean, we were creating something from the ground up that required a very stringent set of parameters to include.
Yeah, 3 boundary conditions. I mean, you had temperature, you had humidity, and then you had evaporation rate.
And that in of itself, what we did is David and I worked with this technician on drawing the concept, actually drawing it, top, side, front view, and then letting that person go on ordering materials and cutting up materials. And I remember seeing the first prototype, and I'm like holding my hands here not to stress out. But the first prototype was made with a big sheet of particle board.
Yeah. The beginning of the story goes back a little bit farther.
Oh, I can't wait to hear this.
And
chutes and ladders.
Right?
You talking about the drill?
I'm talking about drilling into to the chamber, yeah. So I mean...
Let's not talk about that.
Let's not talk about that.
Yeah.
Be careful with your safety when you're doing these things.
Right. Yeah. And it was not carrying that attention to the team concept. That is something that we started doing like soon after that during the next design, is that we were constantly meeting and discussing and identifying, okay, this is the direction that we're going to go. Measure twice, cut once with that project.
Right.
we ended up letting that technician go, and I ended up being the technician. Then we hired a contractor to help us out, get finer resolution on our cuts. But the hardest part, I think, that came to building the C156 was the calibration.
Yeah, no doubt. When we conceived of the design, the temperature was so high, 105
Right.
Fahrenheit, something like that. The temperature was so high that we just figured we'd always chase. That, we'd get to 105, it would cool down. We'd chase back to 105, it would cool down. But we had a surprise.
Yeah, and it built on itself.
It built on itself.
We had created such a wonderful insulating environment that it retained that heat, and if we didn't allow some heat to escape, then we wouldn't be chasing it, we would just be building it. And I came in one morning, it was like the chamber was 128 degrees Fahrenheit. I was like, oh shit.
So yeah, we did an excellent job on the insulation and
Right.
energy side, but what we hadn't anticipated was the thermal capacity, the thermal storage of the heating device.
And what we started doing is we actually went back to the Book Creek version of it, looking at the circulation of air
Right.
and changing the directions of certain fans as
Right.
well as the humidifiers, and then using specific types of fan to get circulation where we wanted localized circulation. And it ended up costing us more money. Like, you should hear cha-ching, cha-ching, a new type of fan, different types of fan, different directions of fans.
And the amount of hours we put in that is what ate us up.
Even the calibration cup, the steel calibration cup was like $200 or $300.
It was 300-ish, yeah.
$300-ish. And the time, there would be hours where we're just sitting there, right, staring at the regulators, and we put temperature sensors and relative humidity sensors in there, and we shortened up the calibration windows so we could do it faster.
Right.
But what I think we learned is, and if you're in the business of, if you're a mechanical engineer or software engineer or even hardware, and you develop things, you'll know this, that the first time is rarely going to work.
Yeah, I mean, even if we had done a thermal finite element analysis, I don't think we would have gotten it without some trial and error. It was amazing how much gradient there was in this much distance from the heating element into the box. I mean, it was just absolutely amazing.
Oh dear, I am so sorry.
But thankfully we had a very patient resources group who worked with us and understood that there was a lot of potential. I tell you, that piece of equipment, that C156, we use it. There's very few people who do that test well.
Yeah, and I think that's a key for us as a small business. I mean, we really can't compete and really don't care to compete
Right.
with the major production labs that do,
1,000 cylinders a day.
1,000 cylinders a day, or 100 flex beams.
Ugh,
I mean,
look, no.
that's really not our niche. So our niche really is the unique, the unusual, the difficult, the novel, the new. That's really kind of our niche, and so we go out on that thin ice every so often.
When you two, and not that I want to start a different story time, but just like when we were building the C156 and you and Whitney were building the C666, we used a very specific factor.
It's the Universal Theorem of Pi.
We multiply our budget by the Universal Theorem of Pi, by pi. 3.1415, blah, blah, blah.
Yeah, unfortunately, that works out pretty well most times.
And if we get under that, we're very proud of ourselves, because we're not going to be able to predict, especially with a new piece of equipment, especially when we're altering things that weren't necessarily built for the use that we're applying it to, that there are going to be hiccups. And if we multiply by that theorem of pi, we have more than enough wiggle room, right?
Yeah. Yes.
And if we don't, like, hey, the C666,
Yeah, I know that was a nightmare.
but you still made it within,
Yeah, we brought it in within the Theorem of Pi. So
which you shouldn't have. That was a very, very difficult.
yeah, that one's also multi-boundary condition. It has the cold-warm cycles have to be within a certain rate,
It's just.
That one's also multi-boundary condition.
But what y'all built is absolutely beautiful.
Yeah.
I mean, besides the fact that it works, which is very important, but it does the job well, and it's not that expensive. So it saved us a lot of money. Yes, they were person hours, but
yeah, that one's really expensive. That's in the 50 kilobucks range.
Right. Well, so is the C-156.
Right.
So we intended the C-156 to cost us $1,200. Actually, cost us, I think it was $3,600 to $3,700 at the end of the day. It was not.
I'm pretty sure. It was
You
not.
stop it. Don't listen to Whitney. Where's she know? She's not even in the resources group. That's not true. That's not true. But hey, we got it done. Make some good money off of it.
Yeah, that's the key. If we can get a return on the investment, no matter the overrun, as long as we get the return on the investment,
Right?
it's a good company decision.
Amen. So hopefully you learned something. Let us know if you got any concrete questions, concrete concerns. Don't forget to like and subscribe.
Ding that bell for notification.
Go Concrete!
Beat ass fall.